Welcome back. I'm talking to the future. You're here in the past, in your present. Okay, so engineering, chapter 15, chemical engineering. We're going to go through slides 31 through 35 today. And the idea behind that, the objective here is student will list and explain the factors a chemical engineer might consider when designing a chemical plant and choosing a site. There are a lot of chemical plants out there, but it's also important where are you going to have it? What are you going to do? Because we'll address the safety issues at another time. That would be two more discussions on that. Anyways, so looking at chemical engineering applications, we look at chemical plants. There are continuous chemical plant operations. Some of them, they shut down at the end of the day. Sometimes it could be a 24-hour, 7-day-a-week thing. And this is where they deal with batch chemical operations. Okay, so for example here, the batch chemical plant operation, I need X number of Guy's deodorant. Okay, and that's it. That's a limited run. That's a batch, if you will. Another example would be something like a continuous chemical plant operation where it's an ongoing thing. There's an ongoing demand. So if you look here, look at this picture here where you got the drink mix and the water. Okay, and the chemical plant operation, it's actually making it. And then out comes your sports drink. Yeah, whatever it is. So again, continuous chemical plant operation, you're operating 24/7. You're not shutting down production, whereas when you look at the batch chemical plant operation, it's only for a certain number, and that's it. We don't have to worry about it. And that might be a seasonal thing. Maybe you're making suntan lotion for the spring and the summer, and then by that time, summer is about ended. You shut down production, and now you're going to go and make hand cream for little children. I don't know. But that's the idea behind batch chemical plant operation versus continuous chemical plant operations. So when we look at the design, there's some things you have to look at. And this may be bringing back some memories of I had you guys design certain things as far as your business, what were you going to do? But I also, you may remember, I had you guys do a retail layout of your store, so to speak, where you guys, I gave you parameters, I gave you limits, and that's it. Now here, when we look at the plant layouts, there's some things you have to look at. Economics, okay, in terms of can we make money with this process? Does it cost us too much money? Then we need to change how we do things. The processes, are they safe? Are they, are they safe? Can we make money with it? Maintenance, is it going to cost us a lot to do maintenance? I mean, can we still make a profit if we're looking at maintenance? And then, of course, safety of your workers, safety of the equipment, things like that. Because if workers get hurt, okay, or you have a chemical plant explosion, bad things happen. People get hurt, some cases they die, and you get lawsuits for it. Now, so those are some of the things that the chemical plant engineer is going to have to figure out. Now, there is also the block flow diagrams. And I'm back. Sorry, little interruption there. So looking at the block flow diagram, this is what you guys are seeing here, okay? You got block and it flows. Pretty straightforward, right? So simple idea, chemical 1, chemical 2, combine it in a mixer, and we put it in storage. Okay, now this also works with the process flow diagrams, and we sort of covered that in an earlier chapter about that. So I'm not going to worry about it too much here. Piping and instrumentation diagrams. Oh, of course. You need to know where your pipes are going, where are they coming from, where are they heading off to. Does it have relatively easy access for the maintenance crew to come in and work on it? What if you need a technician to go and access it? Can they access it? Instrumentation diagrams. Yeah, of course you're going to be having instruments like pressure, for example. That would be a good one. You need to have access to that. You need to actually show where would those things be located in designing a plant. Okay, let's try that again. Okay. Now you've figured out the basic floor plan of your chemical plant. You've looked at some basics. What are you going to make? What materials? Now the next thing is plant location. Location, location, location. Reasonably close to raw materials and energy resources. Yeah, that probably would be a good idea. Unless you happen to be a chemical plant out in the middle of the Death Valley area called Trona. Trona is a chemical plant out there. They have a high school out there. Long ago, our football team played against those guys and got creamed by those guys. They don't have a grass field. They don't. That's a luxury for them out there at Trona High. Okay? So, having access to raw materials, having access to energy resources, that's an important thing to look at because it's also a question of cost. Because if you build in an area that may be cheaper to build, but it's more expensive to bring in your energy resources, it's more expensive to bring in your raw materials, that might be something you would not want to consider. Okay? It's called chemical engineering in the real world. Now, local communities should be considered. How come? I mean, think about it for a moment. Why would it matter to consider the local communities? What do we have going on there for that? I'm going to take a stab at it here. I'm thinking perhaps safety for the people in case something does go wrong with the chemical plant, like an explosion, perhaps. And maybe it's a little a ways from the town, so it's not raining death and doom and destruction on the townspeople. That might be one consideration, a safety thing. The other thing would be an economic thing. If you build a chemical plant near a small town, that all of a sudden you now brought some jobs into that small town, and that kind of helps the people out, helps the local economy too. Some things to think about. Another thing to look at, guys, would be a property that's large enough for the facility with future expansion. Now, if you're talking about within the city limits of Los Angeles, that's more of a challenge because LA is pretty much developed. And certainly you're not going to have a chemical plant in the middle of New York City. Not possible, not happening, couldn't get the permits. Okay? So those are things that the engineers are going to have to look at when they try to go and set up a chemical plant. It's getting late. All right. Let's wind this one down. Site layout. Specific location for all required facilities. The plant, the road, the parking, stormwater management. Yeah, what if that freak chance that you don't have good flooding management at that chemical plant? Yeah, that just might now spread the chemical out all over the place where it wasn't wanted. Again, things like that. Same thing for utilities. And again, allow for efficient flow of materials through the site. Is it easy to get the stuff to the site? The power, the raw materials, the people. All those things are considerations when you're looking at a site layout. Hey, we're winding down. Woo! Waste. Oh, yeah. Waste is inevitable. It's a byproduct of chemical operations. Now, sometimes what is waste to one plant may be raw material for another. So let's say you're making something and your waste, your byproduct, is ammonia. Now, ammonia smells, but you could bottle the liquid and you can sell it to other companies. Well, what would they do with it? They can make household cleaner out of it. They can make fertilizer out of it. So there's some different things that can be done with it. Okay? So, but there are sometimes there's waste that you got to get rid of it. And how do you get rid of it? And that's where the cost of disposal is a major consideration. It's not easy to go and just throw stuff away. There's a responsibility that's involved in that. So you have to think about it. So how can we go deal with that? Well, one way we could do is maybe minimize the waste. Or maybe there's some parts of it where we can recycle it, reuse it in the process. Something along those lines. Now, there is also the disposal. The disposal must meet local regulations as set forth by the local government. That's a pretty important thing. Usually that's the state or the federal level. Okay? If Nowhere County says it's okay to dump it here, the state of I don't know may have an issue with that. And if the state of I don't know says, yeah, it's okay to dump it there, the federal government of I have no clue says, nah, that's not okay. You got to find somewhere else. So that's all. There's a lot of regulations involved in that. Disposing waste is a big deal. Okay? And part of it, guys, is being a good steward of God's earth. When God said to Adam and Eve, hey, go out there, multiply, subdue the planet, that did not mean, hey, Adam and Eve, you can multiply, be fruitful, you can do whatever you want with the planet. No, that's not what God meant. Okay? And that's something for you guys to think about. Hey, we're done here. So, what did we cover? We talked about the idea, the factors involved in having a chemical plant. We talked about dealing with waste, dealing with site layout, dealing with the plant location. We looked at the plant design. How are you going to go design a plant that you're going to be manufacturing something safely, efficiently, economically? Okay? We looked at the concept of continuous chemical plant operation versus batch chemical plant operations. We also looked at the idea of temperature measurement devices, because that's certainly a critical thing to measure, like thermocouple sensors. We talked about bimetals. Okay, we looked at devices. Then we also looked at pressure, measuring pressure, like the liquid column gauge, for example. Talked about the idea of what is pressure. And with that, ladies and gentlemen, we are done here. Okay, our next one is going to be dealing with chemical safety, and that is a twofer. One is on your notes, one is something separate. All right, take it easy, guys.